Hi, I'm Dala, and in today's video I'm very excited to tell you all about what's happened in the last 2 months regarding Battery-Emulator progress and also a quick start guide on how to take into use this new software. So if you're only interested in watching the quick start part of this video, skip ahead to this timestamp right here. But before we get into that now, let's discuss a bit what has happened with the project. So, 2 months has passed and we have been very hard at work developing this software. So, some of you might have noticed that this project is just growing way bigger than anyone would have anticipated. If you look at GitHub right now, we are approaching 2000 stars, which is like amazing for an open source project. And the user base for this whole project is growing also very large. I think from my own estimates that around maybe over 1,000 installs have been done using this software. It's a bit hard to keep track because no one is obliged to tell us back if they are using the software. But companies are using them. Some companies have deployed over 50 projects with this, and also so many individuals are taking energy independence into their own hands with this software. So yeah, we have been hard at work making it easier to use the software. If you have watched the previous videos on how to set up this Battery-Emulator project, you know that it has been quite complicated to compile the source code from scratch and configure it to take it into use for your own project. And we hear you, and we have developed a new, better method. So it is no longer required to install any IDE and compile the software. All that is gone. Everything is done via web browser. But I will show you more about that later when we get to the actual quick start guide. So yeah, accessibility is maybe the biggest thing that's new in this version 9. But there are also other improvements. And one of them being the new support for newer CPUs and new hardware types. So we are now supporting the ESP32S3 CPU style, which will enable newer hardwares to be used with the project, and especially budget options. The new software also contains things like support for newer batteries, like Rivian batteries, very large batteries, 150 kilowatt hours, wow. And newer FD batteries like Kia 64 kilowatt hours, and other things like Relion LV batteries, new inverters such as SolaX and Grovat VIT, etc. You can check out the release notes. I'll be sure to also show these here later on in the video. So there's a lot of things have been happened for the last 2 months. So it's finally time now to release version 9. And before we do that, I want to trace back to the hardware selection aspect of the Battery-Emulator, because a lot of things have happened there. So, as most of you know, the project started out with this LilyGo TCAN 485 board, which is a very inexpensive board. It's only like 10 euros. And that's what the project started with, really cheap available hardware that anyone can buy. But then the project started to get more and more professional, so we needed better options. Then also the limitations of this board quickly came into play, because it has only one CAN interface and one Modbus interface. So you can add one battery and you can have a Modbus inverter, or if you're lucky, you can have a CAN battery and also a CAN inverter shared on the same port, if the inverter is okay with that. But that quickly led to the development of adding on CAN boards to this LilyGo board. But I really don't like this option a lot, because it adds complexity to the system. Users might connect these wires wrong and bad connections, etc. So yeah, this was not really optimal. So I was very, very glad when Johan Stark started to develop the Stark CMR, which is, in my opinion, the best way to actually use the Battery-Emulator project. With this board, you will get double CAN inputs and also a Modbus input, and you get CAN FD, tons of GPIO for contactor control, etc. and also nice status LEDs. This hardware is like professionally made, it is CE certified, etc. So like this is the best option if you are just starting up the project. It is a bit expensive compared to these cheap China boards, but of course if you're spending like thousands of euros building a really cool battery project, why go for the 10 euro Chinese microcontroller when there is like professional hardware available that will last way longer. So yeah, this is really what I recommend. But I understand that not everyone has the budget to go for professional hardware, so we hear you. We have also now included support for a new type of board in this version 9. And this is the LilyGo T-CAN board. So this board has two CAN inputs instead. And if we compare that to the original LilyGo board, which had a Modbus and a CAN, then this one is much better because a lot of the inverters that people use in this project, they are not Modbus. So this is like a much better budget alternative, that you get like two CAN ports and you don't need to mess around with this adding via wires, etc. You can just go for this board if you need a good budget option. So that's kind of where the hardware solution is at the moment. So all these three boards are very well supported now by the software, and you can take them into use today. Worthwhile mention is that new boards are coming. We also have this open source 3-CAN board, which is still under development. We're hoping to release the support for this soon also. So be tuned for this if you need like 3 CAN buses. I guess that's it for the hardware part, and I would then maybe start with the actual quick start guide. So let's talk a bit more now about setting up the hardware for your specific components. Okay, so all you need to get started is a laptop that can open a web browser. You need a USB cable. Make sure that the cable you're using is data capable. There are lots of cables that only do charging. And of course, finally, you need the board that you're going to be installing the software on, either a LilyGo board or the more professional Stark CMR. The process is the same, whatever board you use. So let's get started. Okay, so let's get started with the initial flashing setup. I have the GitHub page open here, and I'm just gonna scroll down here to the how to install the software guide, and yeah, you are watching this video right now. But the first step is to open the web installer page. So I'm just going to click this. And this will install a factory image onto the device. So I have now plugged in the LilyGo board that I want to flash. I'm using a T-CAN 485. So now I'm choosing the latest release, which is version 9. And I'm going to choose the initial image correctly. This is very important that you select the correct one for your hardware. So I'm using the T-CAN 485. And then the next step is to install it. If you get an error message here saying that your browser is not compatible, then you need to switch to a supported browser, like a Chromium-based one like Chrome or Edge. I'm using Chromium here. Then I'm connecting to the board. I'm using this USB single serial port. It also depends a bit on your operating system. If you're on Windows, you might have a COM port for it, etc. So you can just try to plug the board in and see if a new port appears. That's most likely your Battery-Emulator board. So now I'm connecting to it and connected successfully, and I will click this Install Battery-Emulator. And yeah, I will just go ahead with Next and Install. So this flashing will take roughly 2 minutes, so I will just skip ahead. Okay, so the flashing has completed, and I can already see here on my board that the LED on the Battery-Emulator is flashing green, so that means everything was successful. That's it, you are done. Now we can actually start to use the board. So now that the software has been installed, it will start to broadcast an access point. So now you can either do this from your phone or you can do it from a laptop. So now I'm going to connect to this network. And now it's going to ask for a password. And the password is 1, 2, 3, 4, 5, 6, 7, 8, 9. And we connect. And now we should be able to visit this web page to set up the board. So I'm just gonna copy this link and open it in a new tab. Oops. Maybe we should make this link clickable in the next version. Go to. So now we're connected to the Battery-Emulator board. So if we click here back to main page, we can see that yes, software was successfully installed. And now we can change the settings. Before we go and set up actually battery and inverter config, I'm going to show you a way to make the software a bit more cyber secure. Because right now we are broadcasting an access point, and it's a bit more secure to have it connect to your local home network instead, so that you access it via that instead of your actual like hotspot, because anyone could connect to that hotspot. You can also, of course, change the password on the hotspot, but I'm just going to go ahead and connect it to my home network. So I'm entering the SSID, and I'm also going to enter the password. Okay, so now the Wi-Fi has been set up. And this might require a reboot. We can see here that the Wi-Fi state is idle. Sometimes you can get it to connect. Oh, actually we got it to connect. So it is now connected to my home network. And now it's gonna broadcast an IP address here. So now I'm gonna remember this IP address, and I'm gonna switch back to my home network instead and continue doing the setup via that. So now I'm connected to my home network instead, and I'm just gonna replace this whole go to, and as you see now I'm connected via my home network to the Battery-Emulator. That's great. And now actually when we have done that, if we want to make it really cyber secure, we can go down here to the connectivity settings, and we can untick this broadcast Wi-Fi access point. That will turn off this Battery-Emulator Wi-Fi network. Remember to click save if you want to do this. But that's it. That's how you install the software. I think next up should be to actually go through a few examples and see how to configure it. First up is the classic Nissan Leaf plus Afronius inverter. So I'm going to put the diagram up here on screen, what I'm trying to achieve. I'm using a LilyGo with the Fronius connected to the Modbus input and the battery connected to the CAN input on the LilyGo TCAN 485 board. So as a battery, I'm going to scroll down here and I'm going to select Nissan Leaf battery, and it's connected to the native CAN port of the LilyGo. If you are unsure which interface is valid for your hardware, you can check the wiki page and it will explain that in more detail. So I'm setting this as native CAN. Chemistry on this is actually NMC, and that's it for the Nissan Leaf config. Then inverter side, I'm using a Fronius Gen 24, so it's gonna need a BUD battery over Modbus RTU, and this is connected to the Modbus interface on the LilyGo. Then we have some extra options, because we're also using contactor control on this setup. So we have the GPIO directly connecting to the relays or contactors inside the battery. So I'm going to enable this contactor control via GPIO, and that will enable those outputs. You can also select PWM in case you are using SSRs here for lower power consumption. That's it. We are done with the config, so I can just here click save. It will save the settings, and it will say settings saved, reboot to take new settings into use. So then I'm gonna reboot the board, and now when it refreshes, we will see that we took into use BID protocol over Modbus RTU with Nissan Leaf battery. So that's it. We can also here see what the contactors are doing and if it's gonna close them or not. So yeah, that was very simple and much easier than before. Next up. Okay, so next up I have switched to a Stark CMR board, and I'm gonna do a bit more complicated setup. I'm gonna be running double Nissan Leaf batteries. So if you go into the settings, let's set this up. We are using a Nissan Leaf battery, and I'm not gonna require the interlocks. The first battery is connected to the native CAN port of the Stark board. That's the one as CAN 1. And then I'm going to set the chemistry and enable double battery. And then the second battery is connected to the native CAN FD port of the Stark board. That's the one that is labeled CAN 2. Then I'm gonna also here in the hardware config, I'm gonna make sure that I have selected use CAN FD as classic CAN, because we're not using FD, we're using like classic CAN protocol. Then also setting the inverter control as before. We want the Modbus inverter for the Fronius hooked up to the Modbus port. And finally, we also want contactor control here. So I'm gonna enable that, and also that the secondary battery is also controlled via GPIO. So then I'm gonna save this and reboot. And once it has rebooted, we should be seeing 2 batteries controlled at the same time. Yes, and the interface is Modbus for the inverter. This is excellent. And here we can see that the secondary battery will be able to join the DC link once the voltages match. Right now I'm just don't have anything connected, so it's just a simulation, so it will not actually close that secondary contactor. And you can see the wiki for more info on how to wire it up. Okay, next combination. Okay, as the next combination, I have a Liligo T2 CAN board, which has dual CAN channels. And this board I'm gonna configure as a Tesla and SolaX inverter. So as battery, I'm gonna select the Tesla Model 3, because that's what we're running. And as you notice here, there are quite a lot of options for the Tesla batteries now, because we are emulating the full vehicle. So for these batteries, it's very important that you select all the correct options that apply to your battery. So for instance, here now I know that this is gonna be an European German battery from a Tesla Model 3. And yeah, just like that. And for Tesla, we also need to define some charging speed, because the Tesla protocol requires this. You can look more on the actual wiki page for each battery in case they have some special configuration options. And I'm going to connect this to the native CAN channel on the board, and then I'm going to select the inverter also, which is going to be a SolaX inverter, and that's going to go on the secondary CAN channel. That's the CAN MCP2515 add-on board. And for SolaX, there are also some extra options here, and I recommend that you read the SolaX wiki to properly understand these settings in case they are or need editing for your setup. And that's it. I'm gonna go ahead and save the settings, and there we have it. Now this board is emulating a Tesla battery and a SolaX inverter. Nice. One thing that is really cool about the Battery-Emulator now with the version 9 is that over-the-air software updates are gonna be very easy to perform. So if I go here and take the latest release, version 9, and if I want to update, say, this Stark board that's running some old 9.0 dev, I can just scroll down and I can click this Perform OTA Update button. And here it will prompt me to select a file that I want to update to.
So I'm just going to scroll here down for the release notes of version 9. And here at the bottom we can see the assets section. And we have the Stark CMR OTA bin. So very important that we take the one that is for the correct hardware. So now it's going to download that file. And I can go back here into the OTA update, select file, just going probably to my downloads folder. Here it is. And now it will be uploading this file. And the really nice thing is that I don't have to reconfigure anything. Like all the settings have been stored already to persistent memory. So now that I'm rebooting this board, it should use the exact same setting as it did before. So now it's rebooting. And if everything went well, this board should be running 2 Nissan Leaf batteries and a Modbus inverter. And it does. Check that out. Latest firmware, no need to change any settings. Wow. Over-the-air updates just got even better. Very nice. As a final note here on the settings page, as you noticed, we can emulate so many different protocols and have support for so many different batteries. So I could be talking here all day about different protocols. But instead, it's much better to go to the wiki page for your specific battery and learn more about how to configure it. The same thing goes for batteries and inverters. Final notes here also is that all the settings that you see here in this green place, they require a save and reboot to take effect. We also have the older settings here that you might be very familiar with how you change if you want to rescale SOC or change charging speeds. This is working exactly the same as before, so you can just change these settings on the fly. But all of these settings up here, they require a save and reboot to take effect. That's it. I hope you enjoy this new release of the Battery-Emulator, and be sure to report any bugs or give feedback in case you notice something or think we can improve somewhere. Thank you for watching this quick start video, and see you in the next one. Bye.